music?
Yes, sir. Light music, sir.
Okay.
Not a problem at all.
Okay. So today my relative's marriage is there.
Oh, from there you are giving us
Ah,
classes, sir. Thank you so much.
yes, I'm relative marriage is there. Any
Okay.
disturbance? Tell me. Shall I back and tell you? Okay.
Yes, sir. No, sir. It's very
No, no,
clear.
no, no, no. Any disturbance for between in the term? You tell me.
Oh, okay, sir. Sure.
Last week, which number we had taken? Which 7 point?
Sir, almost seventh unit completed, sir. I think.
No. 7 point
Covariance.
covariance over 7.3.7.
Yes, sir. Covariance completed. 1 second, sir.
7.3.8 random variable also completed. 7.3.11 I think not completed. So you can learn 7th unit. I will go the 8th unit. Okay, na?
Yes, sir. Okay, sir.
Any doubts in the 7th unit? Tell me. The central moments and the covariance here. The central moments and the covariance. Tomorrow I will tell in the laptop. Any doubts today? Okay.
Okay, sir.
The central moments is around the d g of x is equal summation of g of x and p of x. E g of x and d of x is discrete random variable, and p of x is PMF, and integration of minus infinity to g of x f of x dx is a continuous random variable. But we have to replace here g of x minus x bar. X minus x bar means x bar is the average of total of x. Clear?
Yes, sir.
So e of x minus x bar, e of x minus x bar, whole dash is equal to summation of x minus bar p of x. If x is discrete random variable. So discrete random variable is the limited condition, correct? It is the limit value. So that is in continuous random value is a indefinite value, correct? So integration of minus infinity to x minus x bar whole power or f of x dx. If x is a continuous random variable. Continuous random variable means E x minus x bar whole power r is called ortho moment about the mean and nothing but central moments here. The central moments are denoted with mu r. So therefore mu r we can write here E of x minus x bar. E means E of x is variance. So we are taking x minus x bar here. So what is the mean and the mean bar? In particular, we can get that E of x minus x bar is equal to E of x minus E of x bar. So already yesterday I told that the last class mu of 1 is equal to x bar minus x bar. That is mu1 minus mu1 bar is equal to 0. Correct?
Yes, sir.
So mu is equal to E minus x minus x bar called variance. Mu3 is equal to x minus x bar whole cube is third central moment. We can learn this 8.31 also we learned, I think.
Yes, sir.
Yesterday last class we can told that this one.
Page number 270.
Just a minute. 8.3.5 also last week I told that.
Yes, so similar. See, these properties of variance is similarly like covariance, right, sir?
Yes. 8.4 properties of covariance. Now we can. So in 8.4 properties of covariance of AX BY is equal to AB covariance of XY. So Tokyo, by definition of the we have covariance of x minus E minus x and Y minus EY we are taking here. So therefore covariance of AX BY. So E of x minus E of AX. What is the A is constant here? Then B of I and E B of I. It is a B constant here. See here, I am taking E of x AEY. AEX, I am taking E of A of x in place of A, that A I am taking in front of, so AEX I am writing. So then BXB and BEY. So I am taking the A common here from the above equation, AX minus EX and BY minus Y. I am also taking B also common here. So AB, E of x minus E and x minus EY. So it is covariance of Y. It is correct? Samhita, correct?
Yes, sir. Your voice is not clear, sir. So
now clear? Now clear?
Yes, sir.
Now clear?
Yes, sir. It's clear.
Okay. So yes, sir. That is the A. Now clear?
Yes, sir.
Okay. I'm asking within 2 to 3 minutes again and again. Why? Because it's listening or not. Yeah. If not properly, you did not listening my voice. Tell me. Okay.
Okay, sir, sure.
Immediately tell me, I will go that another place also. E into A of x minus Ex and B of y of E minus y. AB into E of x minus Ex, B x by y minus Ey. E minus x minus E minus x and y minus Ey. That is, we can write here AB covariance of xy. Then show that covariance of x plus A and y plus B, that is covariance of xy. By the definition of covariance of xy, know that E of x minus Ex and x minus Ey. The covariance of x plus a and y plus b, we can write E of x plus b, and E of x plus a and y plus b and E of y plus b we can write here. But even though we are writing here E of x plus a minus E of x minus a. What is E of x? E of x plus a is E of x. Then E of x minus a.
So getting a lot of disturbance.
Plus a
It's
minus a.
sucking in between.
Plus a and minus a is cancelled, correct?
Yes, sir.
Hello? Just a minute, stay on the line for 1-2 minutes, okay?
Okay.
Just a minute, stay on the line for 1-2 minutes. So now I'm audible?
Yes, sir. It's very clear now.
Okay. Just a minute. I am going to another place. Just wait.
Yes, yes, sir.
So it is the screen is visible, Samhita?
Yes, sir. It is very visible, sir.
Okay.
And you...
Just a minute. Properties of covariance, I'm telling that the AV covariance phi. So then that the covariance of E of x minus E of x minus ye minus y. So therefore we are writing covariance of x phi. Then we can show that the covariance of ax plus b cy plus d is called AC covariance of xy. So what is AC covariance of xy? So here by the definition of covariance xy, we can take here E x minus Ex and y minus y. That again that we can write here constant we can write in the front here. So covariance of ax plus b plus d is equal to ax plus b minus a plus b, and c plus d and e plus d. And taking the constants in front, that e of x plus b minus x minus b, c plus d minus e minus d. So I'm taking the conditions of the constants from a and c for the above equation. D of x minus e minus x and y minus e minus y is equal to AC covariance xy. Am I correct?
Yes, sir.
Yes. Shravanya, you're listening? Okay. Show that covariance of ax plus by cx plus dy, AC variance of x plus BD variance of x, AD plus BC covariance of x. This is also same, Samhita. If you get doubts tomorrow, I will clarify in the system. Prove that the covariance of independent of change of origin but not scale. Very most important, this one. This is let u is equal to x minus a by h, v is equal to y minus b by k. Where a comma indicates change the origin, H comma k indicates change of the scale. Therefore, u is equal to x minus a by h, v is equal to y minus bk. So therefore, x is equal, we are multiplying here x, we can take that of one side here, x is equal to u, a plus uh, and y is equal to b plus yk. So consider the variance of x and y. So therefore, we can take covariance of xy, e is equal to x minus ex and y minus ey. So therefore, a plus hu minus e plus hu, b plus kv and eb plus kv. Again, I'm taking the h and k constants and they're taking the from, and hk taking for the constants, they're taking the common. Hk e u minus e minus v, v minus e minus v here. So that is the basic mental here. So that is hk of covariance of it. Clear?
Yes, sir.
Okay, then we'll go to the another problem. If the probability distribution of x is equal to minus 3 is 1 by 6, 6 by 12, 9 by 3. See here, minus 3 into 1 by 6, 6 into 1 by 2, 9 into 1 by 3. Calculate and tell me what is the answer, is or not. First. Answer is correct or not, check properly.
Yes, sir. Correct, sir.
It is 5.5.
Yes.
5.5.
Yes, sir.
Okay. E of x is equal to summation of x square. Summation of x square x on. So we can take here that one of the condition. That one of the condition. Check it is correct or not. This 46.5 correct, Samhita?
Yes, sir. 1 second.
Oh. Again check also.
Yes, sir, it's correct.
Again, v of x is equal to e of x square minus e of x square whole square. This is also,
Sir,
you can
correct,
check
sir.
that 16.2 also check here. So you can
Yes,
check
sir.
your progress. Check your progress. You can learn that this is agent very easy. Okay.
Just the properties of variance and covariance. Okay, sir.
Yes. The 9th unit I am going here. Today,
Okay,
today 9th unit completed. 10th and 11th tomorrow. 12th unit complete on Sunday. Okay.
okay, sir. Right.
Addition and multiplication theorems. Addition theorem of mathematical application. Addition theorem of expectation of two random variables. So that is, we can take here, if x and y be a continuous random variables with PDF of xy and marginal PDF of f of x and f of y respectively, then by d of x integration of minus infinity to infinity x f of x dx, then e of y integration of minus infinity to infinity y f of dy. See here, e of x plus y integration of minus infinity to infinity minus integration of minus infinity to x plus y f of x comma dy. So we can write here xf. So we can take the common xf or not.
Sir, common, huh?
No,
Sir,
no, here
no.
f of xy dx. So integration of dx is so we can write here a dx. We can write
Yes,
here,
sir. Obviously. Yes, sir. Just
okay.
splitting x and y to f of x.
Yes, x and f and y and f x y dx we can write here. Integration of x, integration of y, f of x y dy, the x integration of x y, integration of y, f of x dy dx. So integration of x y from x y f of dy. So ex of plus y is dx plus dy. So addition theorem of the mathematical mathematical expectation of three random variables. So we can take the statement here. If x, y, z, the three random variables, ex plus y plus z, that is ex plus ey plus ez. So for two random variables, ex plus ey is equal to ex plus ey. So e of x plus y z equal to ex plus e of y plus e of z. 4 unte 4 తీసుకుంటాం, 5 unte 5 తీసుకుంటాం. Am I correct?
Yes, sir. Yes, sir.
Then we'll go to the addition theorem of the operation of, for a random variables. The mathematical equation sum of a random variable equal to the requirement provide that acceptations if x1, x2, xn, so on, xn, the random variables. If x1 plus x2 plus x3 and so on, xn, ex1 plus ex2 plus O1 exn. So C E summation of I is equal to 1 xi is equal to summation of I is equal to 1 yeah, xi we can take here. For two random variables x1, x2, e of x1 plus x2, e of x1 plus e of x2. Therefore, the theorem is true. Let us consider the theorem for n is equal to r. E summation of I is equal to 1 to r xi. So E I is equal to 1 to r x xi r I plus 1. So I'm simplifying here E summation of I is equal to 1 to r xi plus E of xi r plus. I'm simplifying that is summation of I is equal to 1 r is plus 1 summation E of xi. Therefore, the theorem plus 1 with the principle of the mathematical induction of the theorem for two all values of n. Multiplication of theorem of mathematics, very most important theorem, multiplication of mathematical expectation. Multiplication theorem for two random variables I'm taking here, x, y is equal to f. X and y are two independent random variables, f of x, y, the jointly probability density function, marginal PDF for fx and f of y respectively. By the definition of expectation, we have e of x is equal to integration of minus x to x, integration of, as they are told, x f of x dx, e of y is equal to minus integration of minus infinity to infinity, y of y dy. So exy is equal to integration of minus infinity to minus infinity to infinity. So xy f of dy is the simplification of ex to dy, correct?
Yes, sir. There I think
you have to
of printing x y kada sir akkada.
Yes, xy తప్పు పడింది.
Okay.
Another theorem, the multiplication theorem of mathematical expectation from random mathematical expectation of the product of an independent random variable.
So similarly, like addition theorem, we should take a mathematical
and the multiplication that is a plus b, that is a dot b.
Yes, sir. So by mathematical theorem, we should prove, sir.
That's all.
Okay, sir.
So moment generating function and accumulating generating function. See here, define the moment generating function, state the properties of moment generating function, find the moment generating function, the property function, generating function, obtain the four components in the same moment. See here, introduction. Why is the moment generating function? There are two reasons. Moment generating functions, all moments of the variable. The moment generating function is existently uniquely determines the distribution. The data is the two random variables of the same moment generating function. Then they first have the same distribution we are taking here. So thus we can take here, we find the moment generating function. Determine the distribution. The method is very useful to work on.
Sir, your voice and screen is sometimes getting stuck. Sir.
Now okay.
No, sir.
Now okay.
Yes, sir. Now it is.
Just a minute. Now okay fully.
Yes, sir.
Now okay. Full volume I done. If you find the moment generating function of a random variable, we know the distribution. That the method is very useful. We work on the several independent random variables. So the moment generating function. So let x a random variable. The moment generating function MGF. Moment MGF the random variable property of the function. So m of x is equal to e, t of x equal to integration of e over tx f of x. Integration is continuous random variable. Summation is discrete random variable. I told the last class also, correct?
Yes, sir.
Summation is probability distribution and integration is continuously random distribution. Then we can take that the integration of the summation except to the entire range of x comma t being the real parameter and the being assumed here m of x is equal to have the right hand side absolutely convergent for the number positive number minus h less than t less than h. So m of x t is equal to, we can write e power of t of x, that we can write e 1 plus tx t square x square by 2 factorial, t cube x cube by 3 factorial, and so on, t power r x power r by r factorial. So we can take that e power what is it that 1.
Sir, your voice is
e
not
power
clear.
1. E power 1.
So 1.
Then t into e into x, that is t is a scientific value, that is mu1. Then t square by 2 factorial is mu2. Ex square means mu2. Then t cube by 3, that is mu3, and so on. T power r factorial mu r. Correct?
Yes, sir.
Where mu r is equal to x power r. Integration of x power r f of x is continuous distribution. And summation of x power r is discrete distribution. Correct?
Yes, sir.
Correct. Is the rth moment of about origin. Thus we have that the coefficient of r power r by r dash in moment. Generative function m of xt given mu r, since m of xt is the known as moment generating function. Determining equation with respect to putting 1 is equal to 0. My voice is clear?
Yes, sir.
D power, therefore d power r by dt power r mu of x is equal to t. T is equal to 0. Therefore, I am writing here mu power r by r dash into r factorial mu r minus 1 into t, that is expanding, plus t square by 2 factorial plus 2t is equal to 0. Mu power r is equal to d power r by dt power r, and mu of x is equal to t into t is equal to 0. The moment generating function of the x of the point x is equal to e. Defined of mu of x is equal to about t. X is equal to e power t x minus e is equal to 1 plus x minus e t square x minus a square 2 factor t cube x minus a whole cube, and t power 4x minus a whole power 4 factorial, and so on t power r x minus a whole power r by r factorial. We can write it or not?
Yes, sir.
So that is also, as my simplification is 1 plus t mu 1 t square by 2 factorial mu 2 t cube by 3 factorial mu 3 t power r factorial mu r. It is correct?
Yes, sir.
So hence mu r e of x minus the whole power r is the rth moment of about the point of x is equal to a.
Yes.
Then the theorem moment generating function. Let x1 comma x2 comma x3 comma xn are independent random variables. Then the moment generating function x1 plus x2 plus x3 plus xn is equal to mu x1 m of mu or m mathematical theorem m of x1 plus x2 plus x3 and so on is equal to mx1 t mx2 ఏం చేస్తున్నాం అడిషన్ మల్టిప్లికేషన్ తీసుకుపోతున్నాం అవునా
అవును sir. Yes.
By definition of the generating function m of x of t equal to e t I t of x m of x1 plus x2 plus xn t e t x1 plus x2 plus x1 xn ఈ దాన్ని మల్టిప్లై చేస్తున్నాం బయటికి తీసుకొస్తున్నాం tx1 ఈ బేస్ అన్ని తీసేస్తున్నాం ఈ it పవర్ x1 t it x2 it x3 and so on మళ్ళీ అన్ని సెపరేట్ చేస్తున్నాం ఈ capital E into e to it power x capital E into it x2 capital E into so on up to nth. Correct?
Yes, sir.
Since x1 x2 xn are independent random variables, x1 plus x2 plus x3 xn mu x1 t mu m2 xt multiplication తీసుకొచ్చాం సో దాన్ని ఏం చేసాం అడిషన్ నుంచి మల్టిప్లికేషన్ తీసుకొచ్చాం. ఇట్ ఇస్ కరెక్ట్ ఆర్ నాట్?
Yes, sir. Yes, sir.
ఇవన్నీ డౌట్స్ ఉంటే నోట్ చేసుకో, రేపు మళ్ళీ ల్యాప్టాప్ లో చెప్పినప్పుడు క్లారిఫై చేస్తా.
Okay, sir. Actually, it was done by me already, sir. So
Okay.
no doubt at all.
Prove that mu e of x is equal to mu m of x is equal to ct. There is this constant by definition of moment generating function. Mu of x is equal to that is e power itx. So mu of x is equal to e power itx e power of x x. Therefore mu of x is equal to ct. Therefore mu of x is equal to therefore mu of x is equal to ct. This was very most important. Another most important theorem in this unit. Effect of the change of origin, scale and moment generating function MGF. Let us transform u by changing the both origin and scale. X is equal to u minus h, where a and h are constant. Very most important, Samhita.
Okay, sir. This affect change of origin and scalar, sir. Okay.
Scale. Yes, this is the most important. They will ask in the examination also.
Okay, sir.
By definition, moment generating function m of x is equal to e power etx. The MGF u about origin is given by MUT is equal to E into E power IU, that is E I minus X minus A by H, E I X by H into multiply చేస్తున్నాను, multiply చేసి స్మాల్ E వాల్యూస్ రాస్తున్నాను, ఆ కామన్ తీస్తున్నాను, minus AT by H by కామన్ తీస్తే MX by T by H. It is correct?
Yes, sir. It is.
So where MX is MGF about the origin here, where d of x is equal to mu and h sigma x say sigma. So E is equal to x minus h by h, x minus e x by sigma x minus mu by sigma is equal to z. Is known that standard variate. Thus, the moment generating fraction standard variate z is given by mzt is equal to e power minus m by g of x1 by sigma. There's a remark what I'm here. E of z e x minus mu by sigma 1 by sigma e x minus mu 1 by sigma e x minus mu what we are writing here. So therefore 1 by sigma mu minus mu is equal to all that 1 minus mu 1 minus mu is. Hello,
Sir.
Samhita.
Yes.
Already I told one mu minus mu is equal to 0. E of z is equal to 0. Therefore, variance of z
Yes,
is equal
sir.
to x minus mu by x minus mu by sigma. So 1 by sigma square is equal to v into x minus mu. That is a condition we are taking here. So 1 by sigma square v x minus u. 1 by sigma square is equal to v of modulus of x and v separate chestunam. So separate is a v of x is variance sigma square. Variance of mu is 0. So the area of variance of z is equal to 1. So E of z is equal to 0 and the variance of z is equal to 1. Then the mean value variance of the standard value is 0. Standard value is 0 and 1. Why? Because x mu minus mu is equal to 0 and sigma square minus 0 variance of z is equal to 1. So therefore, the mean and the variance of value is 0 and 1. So say, take another example. Let x is a random variable and assume here, or with the identity law, px is equal to p r 1, 2, 3. Find the mg of mean variance. Find the mg of by definition by. By the definition, generating function mu x is equal to e power tx. So see here summation of r, e power tr, p power r. Summation as r is equal to 1 to e power tr. That is p power r means p plus q is equal to 1. We can write q power r minus 1 into p. Correct or not? P power r.
How, sir?
P power, so we listen here.
Yes, sir. In the question itself. Okay, sir. Got it.
Q r minus 1. P by q I'm taking the common here. So P by Q, I'm taking the common here. How we can take the P? The first equation and second equation summation of the e power tr into q power r. That is the simplification. P by Q into summation of I is equal to 1 to infinity Q into e power t r. So taking again P by Q. Again, I'm taking to P by Q, Q into e power t. Summation of I is equal to summation of I is equal to 1 to infinity Q into t. That is r minus 1. Then P into e power t, that is the summation I'm removing here. Summation removing 1 plus Q into e power t plus Q into e power whole square plus Q into e power t whole cube and so on. We are taking here. Correct or not?
Yes, sir.
P power e power t 1 minus Q into e power t whole inverse. Right? M of x t is equal to e power t by 1 minus Q into e power t. So we can, which is the required moment generating function we can take here with respect to differentiation with respect to 1 d by dt of mxt. The differentiation of this one, we can write here p power e power t. This is the differentiation of d by dx of mxt. P power et by 1 minus qet whole square. That is the differentiation of mxt. We can write here. So therefore, mu1 about origin we can write here. About origin, mu of x is equal to what we have taken 0. Am I correct? Samhita,
yes, sir, it is.
X, that we can write p by 1 minus q square in place of e.
Yes, sir.
Yes. We can write it automatically.
Yes.
So, yeah. So therefore, we can write here p by p square 1 minus q is equal to p. That is why, because p plus q is equal to 1. Am I correct or not?
Yes, sir.
So 1 by p square, but that is equal to 1 by p. So hence mu1 is equal to about origin. What we have to write here? 1 by p. Correct or not?
Yes, sir. 1 by p.
The second derivation, d square by d square dt square mu of x is equal to p power et by 1 plus q power t 1 minus qut whole power cube. అక్కడ స్క్వేర్ తీసుకున్నాం కాబట్టి ఇక్కడ క్యూబ్ తీసుకున్నాము. ఇక్కడ కూడా 0 తీసుకుంటే మీద 1 plus q by కింద p స్క్వేర్. అవునా కదా?
అవును సార్.
అక్కడ 1 minus క్యూబ్ అంటే స్క్వేర్ రాసుకున్నాం. స్క్వేర్ ఉంటే ఒకటి రాసుకున్నాం. అప్పుడు formula variance is mu2 minus mu1 dash whole square is equal to 1 plus q by p square minus 1 by p square. First formula, that is q by p square. The fundamental that is cleared in this one. So another one example you have to learn here. Find the moment generating function x uniform 1. So when the x is uniform 0 and 1, f of x is equal to 1 by b minus a is equal to 1. So mgf, m of x is equal to e power ix. So So integration of minus infinity infinity e power I t x f of x dx. Integration of 0 to 1 e power I t x f of x is 1. Correct or not?
Yes, sir. F of x.
So integration is e power t x by x, that is 1 2. Correct?
Yes, sir.
So we can write here. That is, we can write here 1 to e power t minus e power 0 by t. That is m of x t is equal to e power t minus t, which is the required moment generating function. Here, check your progress. You have to do any doubts to ask. Some conditions of moment generating function. Some conditions of the moment generating function is the most important in the short bits. A random variable x of no moments, although it is a moment generating function, exists. And also a random variable x has been moment generating function, and some all moments the MGF does not generate the moments. A random variable x and all the moments but not exist except perhaps at the point. Correct? These three are very important. The short.
Okay.
Cumulative generating function. Cumulative generating. The cumulative generate, let x be any random variable. That the cumulative function, the x is defined by k of x is equal to log n xt, provided RHS in the expanded convergent series powers of t. So k of xt is, you can write here xt, and k2 t square by 2 factorial, k3 by t cube by 3 factorial, and k for t r by r factorial, that is log mxt. We can write it or not?
Yes, sir. That is theorem, I think, sir.
Huh?
Adi statement.
So k of x is equal to log. Statement, the cumulative generating function statement. Statement is statement no manam log m of x digga raasukuntam.
Yes, sir. Okay.
Check here again. K2 t square by t, k3 t cube by 3 factorial.
Sir, what voice is not clear?
Now clear?
Yes, sir.
Log 1 plus mu 1 plus mu r 1 plus mu t. So tomorrow we can discuss this problem on top.
Okay, sir. Okay.
Adaptive property, these major properties tomorrow we will discuss. That this okay?
Okay, sir.
The cumulative functions tomorrow we can discuss.
Okay,
a lot of disturbance is coming.
Yes, sir. And that too, I have practicals, sir, at our study center, so I have to leave.
Tell me. What do you want with that?
Sir, your voice is not getting, sir. I'm unable to answer.
No.
Hello, sir.
Listening.
Sir, it is not audible, sir.
Now?
Yes, sir, somewhat, but not clear at all.
Tell me.
Sir, nothing, sir. Actually, I have a practicals at 1 o'clock, sir. Sir, what?
Tell me, I'm audible.
Yes, sir. Actually, I have practicals, sir, at my study center at 1 o'clock, so I have to leave, sir, for you, with your permission.
Thank you. Okay, great.
Okay, sir. Thank you, sir. Then
tomorrow we will meet again.
Okay, sir. We'll join tomorrow.
Tomorrow we'll meet by 12 to 1. Okay.
Okay, sir. Thank you.
Thank you.